we have concurrent lines that we're going to talk about. Concurrent lines are lines with a point in common. And then we have a point of concurrency. That is a point of intersection. So when we talk about finding a point of concurrency, we want to know where do they intersect. So you have some patty paper at your table. You need to go ahead and step 1, draw a large triangle on patty paper. Okay, so you're going to do this with your groups. Okay, so you're going to start by drawing a large triangle. Now, I would probably use a straight edge. Yes, it needs to be a triangle. It doesn't need to be a wavy lines through wavy lines. Draw a large triangle on your patty paper.
Are we each supposed to do it?
No. We're going to do this 4 times. Okay? Pencil actually works the best. Pencil works the best. Pen doesn't work very well on the patty paper. Okay? Because 1, it starts to bleed, and 2, it also runs. Okay? So now, if you want to go ahead and what? You're going to draw 1 large triangle on 1 piece of patty paper. You are doing this with your partner, so I only need 1 triangle. Okay, that's it. You should then have your remaining ones ready to go. It says construct the 3 angle bisectors for each triangle. Well, if this is your triangle, how would you do an angle bisector? What would you do? Yeah, you'd bisect the angles. So basically, you would fold all of these angles in half, right? You'd fold them in half. So you're going to do this 3 times. So you're probably going to trade off. Okay, 1 does 1, 1 does the other, 1 does the other. So 3 angle bisectors. Fold them and make sure you do a nice fold on those. Okay? Yeah, it's like it's easier to try to look at it this way and then kind of slide it. You see what I'm saying? And then you can slide it down.
Do you want us to like draw?
You did 1, right?
Do you want us to draw the lines that are folded there?
No, I don't want you to draw the lines. I just want you to leave them folded.
Yeah, this one.
Lines up together like that. Yeah. Probably better.
Alrighty, so as you're folding those 3, what do you notice about the 3?
They make a point.
They intersect at a
Point.
point. Now, if you have them folded precisely, you're probably not going to get them to intersect at a total point, but they should. Okay, if you notice this one, intersects right there at the point. Okay? Now, see, if you get a little bit sloppy, you're not going to get them to intersect. But they meet at a point and they are concurrent. So we have a special name for that one. The angle bisectors, they will meet at a point that we call the in-center. Okay, we call that the in-center. So the 3 angle bisectors of a triangle meet at the point called the in-center. So if I were you, you've got your sheet of patty paper, I would label that in-center. It's the word in with center, in center. So exactly as it sounds. So I would label that one.
Fold the patty paper.
Okay. So now, round 2. Draw another large triangle on the patty paper. Now, if you want the easy way, you can take one of your second sheets of patty paper and just place it over your first and trace that triangle, but make sure that you trace it with sides. So I want the person who didn't draw the triangle to do this one. Okay, so you're switching off. Okay? So the person who didn't draw the triangle originally, you will go ahead and do this one. If you want to trace it, that's great. Now, perpendicular bisectors, do you remember how you find a perpendicular bisector on the patty paper? We did this once. Remember how we did that?
Folded the line along the line.
We folded the line on top of itself. So basically, how you're going to do that perpendicular bisector, I'm going to do it, well, I'll do the bottom side here. Okay, I'm going to take that, I'm going to fold it on top of itself so that I meet end to end. And then I'm going to go ahead and crease. Do that 3 times. Once again, I want you to trade off. First person do one, then the next person, then the next person. Right there. You're doing the perpendicular bisector. Yeah. So this is going to be a little different than the angle bisectors. You're going to take end point to end point. Okay?
Like this.
It is, yeah, like that. So now Michaela will do it with the other, or with the other one and then come back.
Like this.
Oh. Okay, so we got to do end to end.
So it doesn't have to go to the vertex, it's numbered and something like that?
Scratch that first.
Made a normal triangle.
You should do that.
Have it done. No, this side.
You gotta do, you have to take this one.
This side.
Yeah.
Oh. No, this side. Take this point to that point. Hey, so what did you notice about these? They also are concurrent, and they met at a point, we call this the circumcenter. So if you want to go ahead and once again label that. Now we could be doing this with our compass as well, and our ruler, our straight edge. We could be constructing these perpendicular bisectors, and they would do the exact same thing. So now if you happen to get done and you want to go ahead and start before I move to the next slide while some people are still writing down, you can go ahead and take another patty paper and trace. Now once again, if you ever want to do these like at home or whatever, you can always use wax paper. That's pretty much the same thing. Are we good to go? Because this is what you're going to do. Okay? Oops. There we go. Altitude. I knew we had one more. Okay, we're going to draw the large triangle, which you all should have. You are going to construct the 3 altitudes. So do you remember how the altitudes are? That's actually what you guys did. Okay. What you're going to do an altitude if I want to find the altitude to this bottom side here, I'm going to start by folding the side over onto itself. I don't want it to meet endpoint to endpoint though. I want to go to the point where I'm going to hit the middle of that angle opposite it. So what's going to happen is when I fold it, I should get a perpendicular. Okay? So this one, you're going to fold the side onto itself, and then you're going to find where does that vertex on the opposite side, where is that going to be at? And you're going to have to pull that one down. Now this one takes a little bit of work, so if you're a little bit leery,
Like that.
I can check and I can make sure before you fold.
So like that.
No. You want to fold this side onto itself, right? So you're going to fold it onto itself. I'm going to just point where my is.
You gotta you would the corner shop. What you do is you take your one corner, fold it like here, so that this is flat, these lines line up, and you just put it back.
Like this? Yeah. All three.
This is exactly what we do for
Yeah. Okay, altitude. Well, no, what was the first thing? So this one, correct. Okay, the three altitudes form the orthocenter. So once again, if you want to go ahead and label that. Now as you're writing that down, there's a question on step 7 that I want you to look at, and I want you to see for what kind of triangle will the points of concurrency be the same point. And I want you to kind of think, don't say it yet. For what type of triangle do you think they'll all be the same point? An equilateral. Okay, I don't know if I've got that there, no. But it's actually an equilateral, okay? Because I didn't have that one in there. But an equilateral triangle will have all those three be the exact same point. And some of you actually were really close to an equilateral triangle just by chance. Because if you notice this one that Jeff and Naomi did, okay, theirs are actually really close. If you line them up, they are all within like a little circle here. Okay, so, and that was just by chance. So depending on if you drew a close to an equilateral triangle, you can see how close you actually were. So now, notice what it says, using your patty paper from steps 3 and 4. So this is the circumcenter and the orthocenter, so hopefully you labeled them like I asked you to. Measure and compare the distances from the circumcenter to each of the 3 vertices. Okay, so you've got your circumcenter here. So this is one where you're going to use a ruler. You're going to measure this distance here to each of the 3 vertices. Okay, compare those distances. Are they the same? All right, so I want you to go and do that with the circumcenter. Also, yep, there you go. So measure that. Find out what you get from the circumcenter.
Like to the side or to the vertex?
To each of the vertices.
Oh.
Wait, no, that's 3.5. Yeah.
So compare the distances from the vertices. Are they the same? What'd you find?
Yes.
Now I want you to compare the distances to each of the 3 sides.
Oh, yeah.
So you did the 3 vertices first. You should have found that those are the same. Now you're going to do the vertices, or the circumcenter to the sides. Now, to the sides, would you?
Yeah.
What'd you get with the sides?
Ours weren't.
They're not the same, okay? So here you go. The circumcenter of a triangle is equidistant from the vertices. So, the circumcenter of a triangle is equidistant from the vertices. All right, so now it says using the patty paper from the first 2 steps of investigation 1, measure and compare the distances from the in-center to each of the 3 sides. So once again, you should have it labeled. So find the distance from the in-center to the 3 sides. So what'd you find?
No.
They're all the same again. So it's equidistant from the sides. So let's recap a little bit about today. Today we learned about the in-center. The in-center, okay, was the point of concurrency for the 3 angle bisectors of a triangle. Okay, next we had the circumcenter. The circumcenter was the point of concurrency for the 3 perpendicular bisectors of a triangle. And then we had the orthocenter. The orthocenter was the point of concurrency for the 3 altitudes of a triangle. So your assignment from this section, pages 181 through 182, you are looking at 1 through 6. Now real quick, okay. Actually, don't worry about doing number 6. Let's just go 1 through 5. Okay, 1 through 5. Okay, so change that to numbers 1 through 5. And that'll be due Monday. Once again, we're looking at our test like Wednesday-ish of next week.